There are a couple of ways to write the formula to represent a sequence. The first of those is what's called writing an explicit formula. So an explicit formula says that if I want to find the nth term of a sequence, I simply just plug in that number for n and I get that value. So for example, if we want to know the 50th term of a sequence, we can plug in 50 into our formula for n, and that will give us the value of the 50th term. So this is kind of a recap from our intro video, that if I have an explicit formula, a sub n equals n plus 1 squared, find the first, fourth, and 10th terms. So the way I'm going to write this is a of 1 is going to be 1 plus 1 squared, right? I'm just plugging in 1 for n, so that's going to give us 4. A of 4 would be 4 plus 1 squared, which would be 25. And a of 10 is going to be 10 plus 1 squared, which is going to give us 121. So explicit formula, I just plug in whatever term number I want, I plug that in for n, I work out the formula, and that gives me that answer. Okay, so now if we have a listed sequence, the goal is to write the explicit formula. We want to look for the pattern, and we want to think about some of those ideas that we had for how to write, hey, these are all the even numbers, or these are all the odd numbers, or these are all the perfect squares, or the powers of 2, or whatever it happens to be. We want to think about those little parts that we're going to use for our formula to be able to write the total explicit formula here. So if the directions are to find the nth term of a sequence, that is what you are trying to do. You are trying to write what the explicit formula is for the sequence. So I notice a couple patterns here, and the key here is when you're looking for an explicit formula, you don't necessarily want to look at, okay, well, how do I get from this term to this next one? And how do I get from this one to the next one after that? No, what I want to look for is, what can I plug in 1 to in order to get this first term of 1/2? And then it has to be the same formula that I plug in 2, and I get this second term of 3/4. And I plug in 3, and I get 5/6, and so forth. So try not to look from term to the next term. Look at, what am I plugging in 1, 2, 3, 4, and so forth to get those values. So I do notice a pattern on the bottom. I have all the even numbers, right? 2, 4, 6, 8, and so forth. I know that the next one's going to be 10, and then 12, and so forth. So I know on bottom all the even numbers. Remember, we're going to write 2 in. If I plug in 1, I get 2. If I plug in 2, 2 times 2 is 4. Plug in 3, 6 times 2 is, 3 times 2 is 6. Plug in 4, 4 times 2 is 8, and so forth. On top, 1, 3, 5, 7, 9, and so forth. Well, those are all the odd numbers, starting with 1. So that's going to be 2n minus 1. If I plug in 1, I get 1. 2 would give me 3, and so forth. So my explicit formula is 2n minus 1 divided by 2n. Okay, so what is that formula that I can plug in 1, 2, 3, 4, so forth, and get that value for that term? B, we have -2, +4, -8, +16, -32, and so forth. So what I'm going to do first of all is I notice that the sign alternates. Negative, positive, negative, positive, negative, so forth. If the sign alternates, I always want to throw in this -1 to the power n. That's going to allow me to alternate my sign. Now, be careful here. I know that if I plug in 1, then I'm going to have -1 to the first, which is going to give me a negative. But let's say you started with a positive. The way that you would adjust this formula is you would just make this either n plus 1 or n minus 1 instead of just n, and then that would start you with an even, and then that would start you with a positive and then a negative, and so forth. Okay, so because we start with the negative, I'm just going to go -1 to the n. And then what else are we doing? Well, we're looking at the powers of 2. 2 to the 4th, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and so forth. So I'm taking this and I'm multiplying by 2 to the n. That's one way you could write it. Now that I know that, I could actually just do -2 to the power n. That's probably a better simplified version of that. But it is always nice to maybe start with that -1 to the n if you notice that your signs are continually alternating there. Okay. All right, just some general tips as you try to write explicit formulas. Some of these things I've mentioned already, whether it be in this video or our intro video. Anytime you see alternating signs, use -1 to the n. If you see all evens, use 2n. All odds, use 2n minus 1. If you notice you are adding to get from one term to the next, it's a linear pattern where what you are adding each time is the slope. So for example, if I see my pattern as let's say it's 3, 4, actually let me do a different one that makes more sense here. Let's do 3, 7, 11, 15, 19, and so on. I said try not to look, hey, how do I get from one term to the next? But if you do, if that's the only pattern you're seeing, right? So 3 to 7 to 11 to 15 to 19, I notice I'm adding 4. What this is saying is that your explicit formula, that 4 is going to be the slope. It's going to be the slope of your pattern. Now, that's not just it. I can't just say 4n, because if I plug in 1, I would get 4, not 3. So what do I still need to do? I would still need to subtract 1. If I plug in 1, I get 3. If I plug in 2, 4 times 2 is 8, minus 1 would give me 7. If I plug in 3, 12 minus 1 would give me 11, and so forth. But the point here is, if you notice, hey, I'm adding 4 every time to get from one term to the next, well, that becomes your slope. If you notice that you are multiplying the same thing every time, then what you end up with is an exponential pattern. So an example here would be if we said 2, and then 6, and then 18, and then 54, and so forth. What I notice here is I'm multiplying by 3 every time, right? From one term to the next term, I see a multiplication by 3. Well, if that's the case, then again, our formula, that's going to be, we're going to be exponential, but it's going to be 3 to the power n. Okay? 3 to the power n. Now, this one's just a little bit tricky because then, well, if I plug in 1, I would get 3, not 2. So how do I get to 2? I can't just subtract 1. Because if you look at the second term, that's not going to make sense. 3 squared is 9, minus 1 would be 8, not 6. So with the linear one, it's this is your slope, and then what do I add or subtract? With the exponential, it's, okay, that's my exponent part, and then what do I need to multiply by? And I would need to multiply, in this case, by 2/3. 2/3 of 3 would be 2, and 2/3 of 9 would be 6, and so forth. So that one's kind of tricky, but and we'll talk more about how to get this later on. But the main idea is, if you notice that you are multiplying each time, use this as your exponent base. Okay, and then just in general, look for more patterns, like all perfect squares. That would be something like n squared, or all perfect cubes. I would use n cubed, and so forth. Looking for those patterns is really helpful when it comes to writing explicit formulas for sequences.